From early creation myths to today's scientific inquiries, the desire to know how life began has captivated people. The scientific study of this phenomenon, abiogenesis, seeks to answer one question. How can a universe that constantly moves towards entropy have ever allowed for life's order? Well, I always say all the best things in life are sweet. So first, let's imagine life as a bakery. To complete the functions key to life, we need 4 types of organic macromolecules:
carbohydrates, lipids, proteins, and nucleic acids. While carbs are important, I want to focus on the 3 more vital ones. Let's think of each as a different cookie sold in the bakery of life.
To bake our cookies, we need crucial ingredients. Luckily, our bakery already has the ingredients we need. All we need to do is mix and bake them. In the same way, to understand how macromolecules are formed, the widely accepted Operin hypothesis explains that all the materials needed to form life were already available on early Earth. The problem is that life itself also requires complex chemical reactions, just like our cookies. But to bake our cookies, we can't just throw all our ingredients onto a table and expect something to happen. We need a container.
Similarly, life requires a molecule that can block off a small space to increase the probability of reactions. That container, the cell membrane, is formed by lipids. Scientists theorize that the lipids that make up cell membranes, phospholipids, were spontaneously formed in hydrothermal vents. These phospholipids have a polar head and a nonpolar tail, the latter of which tend to aggregate in the middle, while the polar heads expose themselves to the surrounding water. A spherical cell shape was thus inevitable. So now we have a container. The only problem is that lipid spheres are naturally unstable. To stabilize them, we need proteins. But how did proteins themselves form? Well, in 2019, scientists discovered that when the components of proteins, amino acids, became encapsulated in lipid spheres, not only were the lipid spheres stabilized, but amino acids could interact to form key early proteins within.
But back to our cookies. I can always mix in all the key ingredients, but without a recipe, my cookies would be inconsistent. And if a batch turns out badly, the bakery would be unsuccessful. Recipes are crucial, even with vital proteins.
If made incorrectly, there would be dire consequences. That's where nucleic acids come into play. They contain the recipe to make proteins consistently. Nucleic acids could also have become encapsulated in lipid spheres, forming the first, well, not life, but some intermediate stage between entropy and ordered life. But that also brings up a key question. What drove chemical evolution to produce these macromolecules? A commonly accepted theory proposes that they only formed because they, like the rest of the universe, conform to the second law of thermodynamics, where nature is driven by the increase in entropy. Essentially, the complex order of macromolecules developed only because of the great heat released through their synthesis and functions. And isn't that interesting, that life exists only because it generates more chaos?
Whatever the answer may be, one thing's for sure.
The theory of abiogenesis, while limited now, may one day truly unravel the mystery of how life was formed on Earth.